The moment the floating raft touches dry ground, the structure instantly dissolves back. For over 100 million years, ants have quietly walked the Earth, outliving the dinosaurs and surviving global catastrophes. Individually, they are tiny and fragile. Yet together, they form one of the most dominant animal forces in natural history. In tropical rainforests across the globe, ants account for up to 20% of the total terrestrial animal biomass. From the scorching sands of the Sahara to the cold, damp forests of Scandinavia, ants inhabit nearly every landmass on Earth. Estimates suggest there are over 20 quadrillion ants alive right now, outnumbering humans by more than 2 million to 1. What makes these microscopic creatures so incredibly successful? The answer lies in their unmatched evolutionary adaptability. Ants are natural engineers, constantly tilling soil, recycling organic nutrients, and driving terrestrial ecosystems. Over 20,000 distinct species have evolved, each perfectly specialized to thrive in its specific ecological niche. They have mastered survival in wild jungles, dry deserts, high mountains, and even human concrete megacities. Their survival strategy relies not on individual intelligence, but on the power of a collective mind, the superorganism. Through continuous cooperation, a colony functions as a single living entity capable of complex decision-making. Deep beneath our feet, they build complex underground metropolises that regulate temperature, moisture, and air circulation. They are fierce warriors, skilled farmers, diligent architects, and compassionate caretakers of their young. In this documentary, we explore the extraordinary adaptations that make ants the undisputed masters of survival. Welcome to Ants, Masters of Survival, a deep dive into the microscopic empires shaping our planet. To understand their dominance, we must first look at the incredible biological machinery of the ant body. Their body is encased in an exoskeleton made of tough, lightweight chitin, acting as both body armor and mechanical leverage. Proportionally, an ant can lift up to 50 times its own body weight, thanks to favorable surface area to volume physics. Their mandibles serve as Swiss Army knives, used for digging, cutting food, grooming nestmates, and crushing enemies. Ants live in a world of chemical scent rather than sight. Their antennae are sophisticated organs of smell and touch. Specialized chemoreceptors detect minute chemical concentrations, allowing ants to navigate completely in total darkness. Hygiene is vital underground. Ants possess built-in brushes and combs on their legs to constantly clean their bodies. A narrow, flexible waist called the petiole gives the ant incredible maneuverability in tight subterranean tunnels. Inside their abdomen lies the social stomach, a specialized organ where food is stored specifically to share with others. Through a process called trophallaxis, ants share liquid nutrients and chemical signals mouth to mouth across the colony. Ants produce potent natural antibiotics from specialized glands to protect their crowded colonies from deadly fungal pathogens. Flexible claws and microscopic adhesive pads allow ants to scale smooth vertical surfaces and walk upside down. Their 6 legs move in an alternating tripod pattern, granting exceptional speed and stability across uneven terrain. Their open circulatory system pumps colorless hemolymph through body cavities, distributing nutrients efficiently. This refined physical architecture provides the ideal foundation for building vast, highly coordinated societies. Every ant colony is built around a central figure, the queen. She is the founder and biological heartbeat of the nest. A single queen can live for decades, laying millions of eggs over her lifetime to sustain the continuous colony population. The offspring develop from tiny eggs into hungry larvae, requiring constant feeding and thermal regulation. Workers meticulously care for the pupae, moving them between chambers to maintain perfect temperature and humidity. When a new worker emerges, it is soft and pale. Within hours, its exoskeleton hardens and its life of service begins. Task division in the colony is governed by morphology and age, a system known as temporal polyethism. Younger workers start their lives inside the nest, taking on low-risk roles such as nursing brood and grooming the queen. As ants age, they transition to higher-risk tasks like nest maintenance, excavation, and perimeter defense. The oldest workers undertake the most dangerous assignment of all: foraging in the hostile outside world. Specialized soldier castes feature oversized heads and powerful mandibles designed exclusively to defend the colony gates. In leafcutter colonies, tiny miner workers ride on leaves held by larger ants to swat away dangerous parasitic phorid flies. No individual ant holds centralized authority. The colony functions through decentralized self-organization. Simple local interactions between neighboring ants aggregate into complex collective intelligence for the entire colony. Together, these thousands of specialized individuals form a superorganism that acts with a single unified purpose. This ultimate social cohesion allows ants to execute engineering feats that rival modern human civilization. Underground, ants construct subterranean cities that can span several meters deep and house millions of inhabitants. With only their mandibles, workers excavate hundreds of kilograms of soil, carefully shaping smooth subterranean walls. Nest architecture features sophisticated passive ventilation shafts that draw fresh air in and vent out carbon dioxide. To prevent disease outbreaks, colonies build designated waste chambers far away from nurseries and food stores. Workers constantly move eggs and larvae up and down the nest matrix to maintain optimal incubation temperatures. When rain approaches, workers quickly seal perimeter entrances with mud and clay to waterproof their underground home. Granary chambers are constructed in dry soil layers, preventing stored seeds from germinating or growing toxic mold. Workers routinely inspect stored grain, applying chemical secretions to preserve their food supplies for months. Some species create supercolonies, networks of interconnected nests stretching across thousands of kilometers. The Argentine ant supercolony spans coastlines across Europe, Asia, and the Americas, forming a global empire. In these supercolonies, ants recognize each other as kin, eliminating internal conflict across vast territories. Underground highways allow rapid transit of resources and troops across large distances without exposure to surface predators. Underground highways allow rapid transit of resources and troops across large distances without exposure to surface predators. These underground marvels demonstrate engineering capabilities that have stood the test of deep evolutionary time. Nature subjects ants to severe environmental catastrophes, but their survival strategies are remarkably resilient. When floodwaters submerge a fire ant nest, the entire colony executes a rapid, life-saving structural transformation. Within minutes, thousands of worker ants interlock their legs and mandibles, creating a self-assembling hydrophobic raft. The physical weave of their bodies and hydrophobic skin trap air bubbles beneath the raft, keeping the structure afloat. The queen and young larvae are placed safely atop the center of the living raft, protected from the water below. Ants on the bottom layer utilize trapped air bubbles to breathe, rotating positions periodically to avoid exhaustion. These living rafts can float across open floodwaters for weeks until drifting safely onto dry land. In tropical mangroves, specialized swimming ants swim across water surfaces to hunt for prey and escape tides. Many ant species can survive complete submergence underwater for over 24 hours by entering a comatose state. To cross water obstacles during foraging, army ants build living bridges with their own bodies, bridging wide gaps. The moment the floating raft touches dry ground, the structure instantly dissolves back into a functional ground colony. Water is gathered and brought back to the nest, ensuring the colony thrives even through extreme weather shifts. As floodwaters recede, workers immediately begin rebuilding damaged chambers, restoring their home within days. This astounding adaptability turns potential extinction events into simple temporary relocations for the colony. Through collective engineering, ants navigate the fury of flooding rivers with unmatched biological elegance. At the opposite extreme lie Earth's scorching deserts, where temperatures reach levels fatal to almost all life. Yet, out onto the blazing Saharan sand steps the Sahara silver ant, one of the most heat-tolerant animals known. Yet, out onto the blazing Saharan sand steps the Sahara silver ant, one of the most heat-tolerant animals known. They run on elongated legs that elevate their body above the radiant sand, moving at speeds equivalent to human sprinting. To avoid overheating, they climb onto elevated twigs for brief seconds, discharging thermal heat into the air. They forage during the hottest minutes of the day, hunting dead insects before predatory lizards dare to venture out. In the arid deserts of North America and Australia, honeypot ants have evolved a unique living food storage system. Specialized workers called repletes are fed massive amounts of nectar, swelling their abdomens into living storage tanks. During long desert droughts, the colony relies entirely on these living storehouses for hydration and calories. Harvester ants in dry grasslands collect specialized seeds, stripping their husks to store dry fuel deep underground. Deep underground, workers extract micro droplets of water from damp subsoil, keeping the nest humid in dry deserts. Without landmarks, desert ants navigate using path integration and polarized skylight to pinpoint their nest entry. Their respiratory spiracles close tightly to minimize water vapor loss, allowing them to conserve vital body fluids. In frigid northern winters, ants produce glycerol-based antifreeze proteins, surviving frozen sub-zero soils. From freezing tundra to sun-baked desert dunes, their physiological toolkit conquers Earth's harshest climates. Survival requires relentless defense. In the rainforests of South America lives the feared bullet ant. Its sting delivers panerotoxin, a neurotoxic peptide causing excruciating pain rated highest on the Schmidt index. In the forest leaf litter, the trapjaw ant uses biomechanical engineering to create the fastest strike in nature. By locking its jaws with internal spring muscles, it fires them shut at speeds exceeding 200 kilometers per hour. If threatened by a larger predator, the trapjaw ant strikes the ground, launching itself into the air to safety. In the canopy of Borneo, suicidal defense reaches an incredible extreme with the exploding ant. When cornered, worker ants deliberately rupture their own abdomen, spraying sticky, irritating toxic goo over enemies. European wood ants defend their massive mounds using long-range chemical artillery against prospective intruders. They contract abdominal muscles to spray jets of pungent formic acid up to 30 centimeters away, blinding foes. Turtle ants possess specialized heads shaped like flat corks, perfectly blocking nest entryways against invaders. Perimeter guards form living razor wire barriers around nest openings, instantly biting anything that touches them. Chemical alarm pheromones spread through the air instantly, recruiting hundreds of aggressive defenders within seconds. Some species drop sticky plant resins and heavy pebbles onto invading insects, immobilizing them permanently. Their combination of mechanical strength and chemical weaponry makes ant colonies near-impregnable fortresses. Every colony stands ready to defend its territory, locked in a continuous arms race against the forest world. Millions of years before humans invented agriculture, ants established sophisticated industrial farming systems. In neotropical forests, leafcutter ants cut fresh green foliage with scissor-like mandibles in seconds. Workers carry these heavy green sails across hundreds of meters of forest trails, returning to underground farms. Deep underground, leaves are brought into massive chambers containing delicate, white fungal gardens. Tiny miner workers chew leaves into moist pulp, fertilizing it with enzymes to cultivate a specialized fungus. The fungus produces specialized, nutrient-dense structures called gongelidia, the primary food source for the colony. Ants carefully weed their gardens, manually removing competing weed mold spores to maintain monoculture purity. They carry symbiotic bacteria on their bodies that produce targeted antibiotics, preventing garden infections. Old fungal material and toxic waste are transported down into isolated deep waste pits to protect healthy gardens. When a virgin queen leaves to start a new colony, she carries a small starter culture of the fungus in her mouth. Over 200 species of higher and lower attine ants practice fungal agriculture across the Americas. This mutualistic symbiosis is so complete that neither the ants nor the fungus can survive without the other. Leafcutter colonies consume more vegetation than any other Amazonian animal, fueling massive underground cities. Their agricultural efficiency demonstrates a level of ecological mastery unrivaled in the insect kingdom. Through farming, ants transitioned from simple hunters into dominant landscape architects of tropical forests. Leafcutters are not the only agriculturalists. Many ant species practice animal husbandry, herding other insects. Ants stroke the backs of aphids with their antennae, stimulating them to secrete clear, sugar-rich honeydew. Honeydew provides colonies with vital carbohydrates, serving as an energy-dense fuel source for active workers. In exchange for food, ants act as aggressive bodyguards, defending aphids against hungry ladybugs and lacewings. When autumn arrives, ants carry aphid eggs underground to protect them from winter frost, replanting them in spring. Similar symbiotic farming relationships exist between ants, mealybugs, treehoppers, and scale insects worldwide. Similar symbiotic farming relationships exist between ants, mealybugs, treehoppers, and scale insects worldwide. The acacia tree provides hollow thorns for shelter and specialized lipid-rich Beltian bodies as custom food. In return, aggressive ants patrol the tree 24 hours a day, pruning encroaching vines and driving off herbivores. Lycaenid butterfly caterpillars produce sugary liquid and chemical signals to bribe ants into guarding them. Some species construct protective barns out of chewed wood pulp over their herds to shield them from bad weather. Ants physically relocate their herds to fresh, healthy plant shoots to maximize honeydew production quality. Underground, root aphids are farmed on subterranean root systems, providing food without ants ever leaving the nest. These complex mutualisms demonstrate the ant's incredible ability to manage and domesticate other living species. Through symbiotic alliance, ants have converted surrounding ecosystems into rich, sustainable food networks. Not all ants are peaceful farmers. Nomadic army ants represent the ultimate nomadic predatory war machines. With no permanent nest, hundreds of thousands of army ants march daily in predatory swarms, consuming all in their path. Spiders, scorpions, and large insects are overwhelmed by sheer numbers and dismantled in minutes. In urban environments, rival pavement ant colonies fight brutal boundary wars over territory during spring. Frontline battles feature thousands of combatants grappling, biting, and spraying chemical toxins over inches of soil. Warfare also takes insidious forms. Parasitic slave-making ants survive entirely by raiding other species. Raiders storm host nests, stealing pupae and bringing them back to raise them as forced labor in their own colony. The stolen workers hatch into a life of servitude, feeding their captors who lack mandibles capable of self-feeding. Parasitic queens assassinate foreign queens, acquiring their host's scent to trick the colony into adopting them. In the microscopic world, conquest and domination are constant realities in the struggle for territorial control. When conditions align after summer rains, colonies prepare for their ultimate evolutionary moment, the nuptial flight. Millions of winged queens and males take flight simultaneously, swarming into the sky to mate and mix genetic diversity. After mating in midair, the queen lands, sheds her wings, and embarks on a solitary, dangerous mission. She burrows deep into the soil, sealing herself in darkness to lay her first eggs and raise the initial brood alone. From a single solitary queen, a new kingdom rises. Millions of years of evolution guarantee their eternal survival.